So it's a great pleasure to have the second tutorial to open the second EU-China Summit. See, please.
Yeah, okay. Now we start the second tutorials for the this EU-China Health Summit. The tutorial topic is FAIR health data sets with HL7 FHIR. New standards to support health research. This is from FAIR for Health project. This topic will cover following information. The tutorial will provide updates on FAIR health data, FAIR verification tools developed by FAIR4Health, the RDA FAIR maturity model, and the HL7 FHIR project. Attendees will be informed how to participate and contribute in the work of HL7 and RDA, as well as join the FAIR4Health community. Now let me introduce the speakers. The first speaker is Catherine Koronaki. Is Secretary General of the HL7 Foundation, a computer engineer, Vice President and President-elect, European Federation for Medical Informatics. She is a member of the European Commission e-health stakeholders group. She will moderate the tutorial session. Esther T is a nurse, midwife, and a PhD student in medical informatics, FAIR data principles, evaluating the fairness of health data at the University Greifswald. She is visiting research at IMISE University of Leipzig, Germany, Leipzig, where her work is focused on testing the FAIR4Health platform from the point of view of client functionality and usability. Ether will introduce the concept of FAIR data. Alicia Martinez Garcia, PhD, she is a software engineer researcher at the Institute of Biomedicine of Seville and executive coordinator for the FAIR4Health project at the Andalusian Health Service in the region of Andalusia, Spain. Alicia participates in national and international research projects on the interoperability, software engineering, clinical decision support tools, health informatics standards, FAIR principles, and model-driven engineering. Alicia will introduce the FAIR4Health project. Anil Sinasi is a computer scientist and a full-stack software developer working as a principal solution architect at SRDC Corp in Ankara, Turkey, with more than 10 years of experience. He holds a PhD in computer engineering. His research area include e-health, e-business infrastructures, clinical research informatics, data interoperability, semantic web service-oriented architectures, interoperability standards, and conformance and interoperability testing. Anil will introduce the FAIR4Health FAIR verification tools. The fifth speaker is Mert Jink Turk. is a computer scientist and a full stack software developer working as a technical manager and researcher at SRDC Corp in Ankara, Turkey. His research area include e-health, national e-health infrastructures, EHR, PHR, data exchange standards, and health interoperability, semantic web data mining, machine learning, security, and privacy. He holds a master's degree in computer engineering and conducts his PhD study on development of a novel federated machine learning methodology for privacy concerned environments in the FAIR4Health project. Mert will demonstrate FAIR4Health verification tools. Oya Bayan is a researcher at Fraunhofer Institute at Applied IT and RWTH Aachen University. Her research focuses on methods of data reusability and fair data-driven transformation and distributed analytics. With her interdisciplinary background in informatics, medical informatics, and sociology, she focuses on societal reflections of data-driven change. In FAIR Plus, Oya contributes to a FAIR maturity model to guide organizations to improve their data processes and delivering reusable and machine actionable data. Oya will introduce RDA and the FAIR maturity model. The last speaker I introduced is Giorgio Cangioli. Is a technical lead of HL7 Europe and the HL7 FAIR4Health project. Since senior consultant of ICT in health and social care, degree in physics, PhD in energy engineering, master in ICT for radiology. Giorgio has worked in the private sector in different roles and has significant experience in the standards and the business process re-engineering health and social care. He served the HL7 Technical Steering Committee, 2002, 2014 to 2015. Authored of DICOM's Supplemental 88, chair of HL7 Italy. Giorgio will provide an update on the HL7 FAIR4Health project and will explain how to participate and contribute. Okay, we have such wonderful speakers will discuss all about all the aspects of FAIR4Health knowledge. We welcome the speakers. And now I give the floor to you.
Thank you very, very much for this nice introduction. Very much appreciated. So without further ado, let's start. Yes, it's about FAIR data and what we are doing with RDA and the HL7 FHIR. And there is a good panel of people that will explain to us all the details. First on FAIR data, then on Alicia with the FAIR4Health project, then some tools from Turkey for the FAIR4Health about verification, then back to maturity models, and last but not least, what we do with standards. So we have actually a small poll question to kickstart the So this is a question about your background. So please answer it to know a little bit more about you. I will leave it for 15 minutes, seconds, yeah. maybe 20 seconds. Yeah, we have 21 people voting, 22, 23, 24, 25. I think that's good. So here are the results. Yeah, so mostly from the scientific community, which is good. Stop sharing the result. So I have, yeah. So yes, what is our mission here? What are we doing here? So RDA, the Research Data Alliance, and HL7, a standards organization, cooperate with FAIR4Health project, which brings the FAIR principles into health data sets to promote FAIR data, findable, accessible, interoperable, and reusable by using HL7 standards and specifically HL7 FHIR. Our goal is to jointly develop tools and guides that enable fairness. And here our objectives today is to help you learn a little bit more. And if we are lucky enough, get a few more people, a few more hands, a few more minds to make things happen. So that's our objective. And for that, I have a second poll for you, which is about your level of knowledge regarding the use of FAIR principles. Again, I will leave it for about 30 seconds for you to vote, to know how much you know about FAIR data and verification and FAIR maturity models. "24 people, yeah, 25. Okay, so I end the polling. And here are the results. So most of you, 16 of you, 59% have a positive idea about the principles of FAIR. Some of you have insufficient knowledge, and I hope we can change that. Yeah, so let's start now. So our first speaker is Esther. Esther, the floor is yours. Please tell us about FAIR data.
Great, thank you. My name is Esther Taino. As you've been explained to, I'm a visiting researcher at the Universität Leipzig and a PhD student at the Universitätsmedizin Greifswald. So I'm going to give an overview of what is FAIR data, which is a general introduction to the audience. Next slide, please. So imagine if your data and your results were recoverable by you or other people who might be interested in it in the future, or if your data was accessible regardless of how you stored it and in the format you stored it in, or if your data and results were interoperable independently of who the author is or where the origin is at, or if your data and results were reusable for further analysis without you having to repeat the experiments. Next slide, please. So in the current situation, you will find that there's a lot of different analog and digital devices that are used to store data, and experimental setups and observations are recorded in a handwritten format in a lab notebook. And for the most part, this lab notebook is independent from digital or analog sources. And then there's different formats. And then all these different formats are then in heterogeneous systems, which are then homogenized. And this is a process that takes a lot of time, and it is a clerical burden for the people who have to homogenize these heterogeneous systems. And then only the owner of these notebooks or of this handwritten notes can read and reuse the data within an acceptable time frame. So anybody else who would like to access that data cannot, because they are not the typical or the actual owner of this data. Next slide, please. Another thing that we have a lot is that we have data being stored on a hard disk or a USB, but more and more people are switching to company cloud servers for data storage. The thing about these clouds is they tend to allow for data sharing and support access authorization within companies, but they are not reusable for researcher groups that are external to the company. Next slide, please. So scientific data continues to be generated in exponential quantities. There's a lot of scientific data being generated day after day. And this creates exciting opportunities for secondary research or for alternative hypotheses to be developed and tested against existing data. As opposed to regenerating data, we could use that same data for further analysis and to explore other research questions. But for this to happen, we need to have this data in a format that is findable, accessible, interoperable, and reusable. Next slide, please. So for the data to be findable, we're talking about that it is easy to find for both humans and machines, and it has a unique and persistent identifier or ID that helps humans and machines to find it in an appropriate way. It has metadata that is rich, and the metadata then allows anybody to use the data for any purpose or to find the data for any purpose. And the globally unique and persistent ID directly connects the metadata and the data sets. And the results, this results in defined standards for data, metadata, and association of data and metadata on different data levels. Next slide. Next slide, please. For the data to be accessible, we mean that the authentication and authorization access has to be known. And there are special tools or communication methods to define who can access the data and who can reuse the data. And the metadata and the condition under which the associated data are accessible is open and free. And that means that even if the data is heavily protected, it can still be free because the metadata is open. And the licensing status becomes more important with automated searches by machines, and the conditions under which the data can be used are clear to machines and to humans. Next slide, please. So when we say interoperable, we are talking about different machines being able to use the data in spite of their differences. And this is made possible through controlled vocabularies or ontologies that describe data sets. And the vocabularies or ontologies need to be well documented and clearly defined. Comprehensive information about analysis, storage, and processing is important for interpretation and knowledge representation. This is extremely important because we need to enrich the knowledge about the data and to create as many meaningful links as possible between data sets and machines. Next slide, please. So for it to be reusable, we are talking about information at all the data levels is made available because the data publisher does not know what the reuser's needs are. So basically, you publish your data or you present your data in a format that assumes that the next person who's going to use it, you don't know who it is, but you're trying to make it as reusable for whoever the next person will be. We call this the next person, the data consumer or the reuser. And so the reuser, for you as a reuser to reuse this data, you need to know where the data came from, who to cite, how to cite, and how the owner wanted to be confirmed. And this is possible it's only possible to reuse data sets if they are similar. That means that they're the same type of data, they're organized in a standardized way, and they're well-established and sustainable file formats. And the metadata and or documentation following a common template and using common vocabulary. Community standards or best practices are important in the reusability of data because for the most part, data is specific to domain. So the uptake of data principles, or rather the FAIR data principles. So after the FAIR data principles has shown improved data stewardship. After the implementation of the FAIR data principles, there has been shown improved data stewardship as a result of adherence to the principles. And so now the FAIR data principles is frequently expected by researchers and publishers and funding agencies and policymakers, such as the Health Research Board in Ireland and the equivalent body in the Netherlands. Next slide, please. So there's a success story I'd like to share. The Harmony Big Data Project, which has verified data from over 45,000 blood cancer patients across Europe. And the Harmony uses this data to quantify the clinical outcomes of particular treatments and decide on the best standards so that they may be implemented right across Europe. So that means if you're in Italy, if you're in Germany, if you're in Spain, you will still get a standardized care because the data has been verified and the verified data is used to inform decisions that are critical to your care. And this approach is beneficial to policymakers, financials, healthcare providers, and especially to the patients. Next slide, please. Those are my contact details. If you have questions, if you would like to collaborate, please feel free to hit me up.
Thank you, Esther. Thank you, Esther. Let's move to Alicia then and learn a little bit more about the FAIR4Health project.
Thank you very much, Catherine. Now I'm going to introduce the main aspect of FAIR4Health projects. Next slide, please. This European project was funded by the European Commission through the topic encouraging the reuse of research data generated by publicly funded research projects. FAIR4Health started on December 2018, is going to finish on November 2021, and it is coordinated by Virgen del Rocío University Hospital as part of the Andalusian Health Service in Spain. The main researcher is Carlos Luis Parra Calderón. The consortium accounts for 17 partners from 11 European and non-European countries with expertise from different domains: health research, data managers, medical informatics, software developers, and so on. Researchers from the Andalusian Health Service, from Health Level 7, from the Institute for Medical Informatics, Statistics and Epidemiology from Leipzig, and from Software Research and Development Consultancy are authors of this tutorial. Next slide, please. In these 22 months, the consortium has performed a lot of necessary relationships. By one hand, with the Research Data Alliance, we collaborate with some RDA interest and working groups. Researchers from the RDA Reproducible Health Data Services Working Group are authors of this tutorial too. In the context of this project, we are working very hard in a new RDA working group on raising fairness in health data and health research performing organizations. Currently, this working group is formally created, and the chairs are from the FAIR4Health projects, Celia Alvarez from the Andalusian Health Service from Spain, and Chamugasudaram Venkataraman from the University of Edinburgh from the United Kingdom. Kristan Khan from the Australian Research Data Commons from Australia, and Anupama Gururaj from the National Institute of Health from the United States of America. The official presentation of this new working group will be carried out next 12th November in the next RDA's 16th plenary. I would like to take advantage of the opportunity to encourage the audience to join this working group on the RDA website. By other hand, we have established relationships too with the European Open Science Cloud through the GoFair initiative, that is a bottom-up, stakeholder-driven and self-governed initiative that aims to implement the FAIR data principles, and the EOS Life project, especially participating in the working group called Turning FAIR into Reality. Furthermore, we are in contact with other European projects as FAIR and FAIR Plus. Next slide, please. The overall objective of FAIR4Health is to facilitate and encourage the European Union health research community to verify, share, and reuse their datasets derived from publicly funded research initiatives. The specific objective number 1 covers the design and implementation of an effective outreach strategy. The second specific objective proposes to produce a set of guidelines to inform a number of RDA recommendations in order to set a FAIR data certification roadmap. The third one aims to develop and validate technological tools to enable the translation from raw data to FAIR data. And finally, the fourth specific objective states to demonstrate the potential impact that the implementation of such FAIR data strategy will have in terms of health outcome and health research through the development and validation of 2 case studies. Next slide, please. The first case study will address the discovery of disease onset triggers and disease association patterns in comorbid patients. And the second one will address an innovative prediction service for 30 days readmission risk in patients with chronic obstructive pulmonary disease. Next slide, please. In FAIR4Health project, recently, we have launched the FAIR4Health Open Community Memberships. I would like to take advantage of the opportunity to encourage the audience to join this open community. To register as a FAIR4Health Open Community member, please go to FAIR4Health website and select the upper option Membership and click the Register Now button. This membership has a lot of benefits to members, allowing take part in the enhance of the collaborative use of FAIR4Health's tools and workflows, facilitating the reuse of the FAIR4Health source code published on GitHub to make your own platform that can be tailored to their own use and purpose, and offering priority in receiving all public dissemination material generated in the context of the projects. Next slide, please. To address the translation from raw data into FAIR data, we have defined the FAIR4Health verification process. GoFAIR defined a verification process without considering specific requirements that may arise when dealing with some particular types of data, in our case, health data. Based on this verification process, we created our verification process taking into account technical barriers, ethical implications, and the legal frameworks. In the diagram, the blue steps are based on GoFAIR process, and the green step has been defined by FAIR4Health projects. The raw data, previous slide, please. The raw data to become FAIR data is going to be analyzed, curated, validated, and anonymized. The data is modeled semantically and made linkable. The license, version, and index are attributed. Some metadata is aggregated, it proceeds, and finally the data go under the process of making it publishable. If the raw data goes under this process, we are going to obtain FAIR data. Next slide, please. The technological solution that we are developing is based on 2 main entities, the FAIR4Health platform on the left and the FAIR4Health local agents on the right in the diagram. The FAIR4Health agents, which will be located at the data owner's premises, will enable the verification of local datasets through its user-driven extraction, transformation, and load functionalities. At the end of the verification workflows, The data sets will be normalized, curated, and mapped to domain vocabularies and ontology, acting like data FAIR ports. The agents are going to execute data mining services to be run locally without the need of hosting these data sets outside the owner's premises. The FAIR4Health platform will act as the facilitator for deploying and delivering innovative data-driven services to the FAIR4Health community by hosting the repository of actionable data mining models that could be executed on real time. The FAIR4Health platform will act as a hub of the federated agents. This technological solution uses HL7 FHIR standard, and its development is in alignment with the EOS initiative, making an essential contribution to the definition of metadata to achieve interoperability of FAIR4Health research digital objects available in the EOS interoperability framework. That's all for my side. Thank you very much for the attention. Below, Anil Sinasi is going to continue reviewing the main aspects of the tool developed until now in the project for verifying medical data.
Thank you very much, Alicia. Greetings from Seville. And now we move to Ankara, Turkey for the tools for verification. Merk and Anil, the floor is yours.
Yes, hello. This is Anil speaking. I am technically leading the design and development of the software that we are doing to support this verification workflow just mentioned by my colleague Alicia. So together with my colleague Mert, we are going to introduce you to the tools and the design and how we implement this verification workflow in our project. Next slide, please. In our architecture, what we try to do is actually to completely cover the verification workflow steps that mentioned by Alicia. You remember the blue and yellow colored boxes, the steps. And we based our design on HL7 FHIR standard. So we utilize an HL7 FHIR standard FHIR repository and build supporting software around this standard repository. As a FHIR repository, we use actually our own repository, which is also an open source FHIR repository called OnFHIR. You can see its source code on GitHub available. And we know that since FHIR inherently provides support for the for some of the verification steps like data versioning, making data linkable, metadata aggregation, and publishing. This is already inherently included in the FHIR standard. So by just using the FHIR repository, we are providing this support for the verification workflow. And on top of this, by using OnFHIR, we have extra features like indexing and search capabilities in distributed environments. So no, previous slide, please. Yes, indexing and search. And also to meet all the surrounding software on a common data model, we utilize FHIR profiling. And again, the profiles that we are developing are open source and available on GitHub. Next slide, please. Around the OnFHIR repository, we developed two standalone desktop applications. The one is called Data Curation Tool and specifically designed for the data curation and validation step. It's available again on GitHub, and we also have a video tutorial of it. You can see this presentation and explore afterwards. The second one is Data Privacy Tool, specifically designed for the data de-identification and anonymization step. These are standalone desktop applications, so you can download and run on your Windows, Linux, or macOS operating systems. The design technology is Electron.js, and the only runtime environment required is JavaScript Node.js platform. So we kindly invite you to explore and look what we develop in FAIR4Health. You can visit our GitHub page to see other software repositories that we are working on. Next slide, please. So this is a schematic representation of our design and what we are developing. At the center of each, let's say, data center or data owner, we deploy a FAIR repository together with FAIR4Health common data mod FAIR4Health profiles. So we provide versioning, data versioning, indexing and search, and data provenance by utilizing FAIR and on-FAIR repository. And the data curation tool can read your raw data from my colleague Mert will present from files or databases and map these data to the FAIR resources, and the conversion is then automatically performed behind the scenes. And data privacy tool just works on a FAIR repository and reads your resources, apply your de-identification and anonymization configuration, and writes back the secured resources into your FAIR repository. Next slide, please. So now I leave the floor to my colleague Mert. I may come in again with the questions if you have.
Thank you, Anil. This is Mert speaking. Now I will present the two tools, data creation tool and data validation tool. Next slide, please. This is the first screen of data creation tool. As you can see, we need to first provide a FAIR repository URL, because the tool will convert the raw data and write to a FAIR repository. So in here, we provide the URL of it, and then we verify, and then we click the next button. Next, please. And then we have to provide our raw data. We have two options in here. The raw data can be in a file, for example, an Excel or CSV, or it can be in a database, for example, PostgreSQL. In this example, we will provide our data through some Excel files. So I click on the browse button on the left side, and then provide my data. Next slide, please. As you can see, I have provided 7 files, each for example, condition, encounter, medication, patient, etc. After I provided this data, again, I click on next to write some mappings. Next, please. So this is the main part of what we do in the data creation tool. If we go from left to right, on the left-hand side, you see the FAIR resources. So while defining the mappings, first I need to select the FAIR resource type. For example, I selected the patient. And then in the second box, I select an existing FAIR profile, which corresponds to our common data model. After that, on the right-hand side, I select the corresponding source file. Since I am mapping the patient resource now, I select the patient demo Excel file. And then I select the corresponding sheet. So after I selected all of these information, now I will start the mapping process. Next slide, please. As an example, for example, I am mapping the gender attribute. So on the left-hand side, I selected the gender field of FAIR. And then on the right-hand side, I say that, okay, gender corresponds to the gender column in my Excel file. After selecting these two boxes, I select the match button. This is right bottom part of the screen marked as 3. And then I match the resource. And I will do all of this for all the required fields in the profile. For example, the patient ID, for example, the birth date, the country, or more. So in this screen, you see that okay, I mapped all my information. And I have another option marked as 2 in the screen. It is the concept map. So the idea is, for example, in my profile, I define some concept maps. For example, terminology standards. But my own data is written in proprietary data format. So I click on this button. Next slide, please. And then I select the source and target formats, and the tool in the background converts performs the terminology mapping, so that all the data will be converted to FHIR in conformance to the profile. So next slide, please. When I scroll down, these are all the mappings defined, for example, for condition, for encounter, for medication, for patient. After I define all my mappings, now it is time to convert the raw data to HL7 FHIR. Next slide, please. So in here, I click on the transform button, and on the left-hand side, you see the red box numbered 1. All of them are completed. And in the box marked as 2, you see the successful count. So I had, for example, if you look at the last one, this is the patient. There were 732 raw patient data, and all of them have converted to HL7 FHIR format successfully. And I can see the details by click on the details button. Next slide, please. So this is an example output of data creation tool as a result of a FHIR query. As you can see in the 5th row, the total number of patients are 732. And for example, if you look at the line number 39, the gender is written as male. Line number 40, the birth date is here. Or line number 43, the country is written as Netherlands. So this part finishes the data creation tool. Now the next part will be to perform the anonymization and the identification by using the data privacy tool. Next slide, please. The tool has a similar user interface like the data creation tool. So the idea of data privacy tool is to fetch data from a FHIR repository and perform some the identification algorithms on the FHIR data, and write back this data in a privacy conserving way. So again, I provide the FHIR URL and I click on next. And I select the FHIR resource. Since our example was on patient, in here I continue with the patient data. I select the patient FHIR resource and I select the patient profile in here. And then the next step is to select the attribute types. For an attribute, I have 4 options. It can be an identifier, meaning that it is a identifier information for the patient. It can be a quasi-identifier, which means that by itself, it does not identify patient, but by using, for example, let's say 4 or 5 quasi-identifiers, I can identify the patient. Or it can be a sensitive attribute. For example, it can be a rare condition, which is sensitive, like HIV, for example. Or it can be insensitive, meaning that there is no need to do any de-identification or anonymization operation on it. Next slide, please. So with this information, I start using the tool. For example, for the gender attribute, the box number 2, for the gender attribute, I selected quasi-identifier. For birth date attribute, I select a quasi-identifier. Or for the first part, for the telecom attribute, I select value as identifier. Next slide, please. And after I select this information, now it is time to configure the algorithms. So the tool allows users to select select an algorithm from several options. Now I will first deal with the quasi-identifiers, and in the second box there are the options. Next slide, please. For example, here are the possible options. We have the pass-through information, meaning that we save the data with no change. Substitution, for example, it substitutes the character in it. For example, fuzzing, in fuzzing we add a noise to the data, or reduction, for example, which completely removes the data. with this in mind, I decide how to de-identify my data. Next slide, please. So I selected my possible algorithms, and the next option is to select from K anonymity attribute. And in here, I have several options, 2, 3, or 5. Next slide, please. And the final step of the identification is to deal with a sensitive attribute. So in here, I have the setting button. Next, please. For example, for the rare values, for example, for the marital status, I can replace, let's say, legally separated attribute to unmarried to generalize it a bit because this is a sensitive attribute for me and I don't want anyone to see a legally separated value. I define this one in here. Next, please. And finally, I click on the de-identify button so that my data will be de-identified. Next, please. And in here, you see that the data of the de-identification operation is successful and the final resource count are written in there. On the right-hand side, you see a field named restricted resource count. This means that in order to satisfy the K anonymity, the tool can restrict some of the resources. And in this example, 19 of them are restricted. Next, please. So this is the output of data privacy tool. For example, if you look at the fifth column, there are again 732 patients in here. In this one, if you look at the column number 32, there is a new meta tag on the data, which is security, and it is tagged as low risk because after the identification process, this data has a low risk to identify the patient. If you look at the 46th row, gender is written as male because I selected pass-through, which means that do not change the data and directly write it. But for the birth date, you see that there is no month or day field, only the year field, because I generalized it in this way, and I said that only keep the year information. Next, please. So these were the demonstration of the tools. Now, finally, I would like to talk about the privacy-preserving distributed data mining part. So in the project, as Alicia presented, we have several agents in several countries. So, for example, on the left-hand side, you see that SAS and YAX are two partners in the project, and these are their architecture. And after we verified the data, we perform some data mining operations on it, and we do it without moving any data to any third-party application. So there are some agents on these partners' premises, and we train some machine learning models on this architecture, and then we move only the trained model, and we generate a boosted model out of these weak models. So this is the final part of my presentation. Now we have two poll questions in here, and we invite you to have a look at these questions. Thank you very much.
Yes, please respond to our first question, which is about privacy-preserving data mining. Tell us what you think. Should verified data be accessible to privacy-preserved data mining algorithms, distributed data mining algorithms? Okay. We have 23 out of 39, so please respond if you are not done. 25, couple of more. Okay, I'm ending the poll. Here are the results. Most of you strongly agree, but there is actually most of you are neutral to that, so you haven't formed your opinion. So let me go to our second question that has to do with privacy preserving distributed data mining. So what would you share if you were to share something? Would you share the data sets or would you share the models? I mean, somebody might want to share both. Maybe we should actually. Okay. There are differences, most of people say, between sharing the models and sharing the data. This is interesting. Yeah, sharing the algorithms. Okay, so let's end the poll. And here are the results. Most of you think that there is indeed a difference between sharing the data sets and sharing the models. And that means that you did a very good job in showing the algorithms and the approach that FAIR4Health is doing. Meanwhile, we have a question that maybe you would like to answer, one of you. Which physiological signal data formats does the curation tool support, if any?
Yeah, I'm going to answer it.
Yes, please.
I was writing, by the way. Do you want me to speak? Catherine?
I mean, answer it live. Yeah.
Okay. So, which physiological signal data formats does the curation tool support? It currently can read from Microsoft Excel spreadsheets and comma-separated values in text format, and can access to relational SQL databases, but it's not fully functional yet.
Okay, I suspect that this question talks about like blood pressure data or this kind of question. Yeah.
Well, actually, it doesn't make a difference for the tool. So the type of the data doesn't make a difference for the tool. Because
okay. Thank you very much. Yeah, I think you answered. Thank you very much for the response. Let's move to the next question. I'm conscious also of the time. As usual, we are. And I would like to give the floor to RDA and Oya Beyan from Fraunhofer, who will talk to us about frameworks for how do we measure fairness. Oya, the floor is yours.
Thank you, Catherine. In this tutorial, Esther nicely presented what is the FAIR data. Then Alicia, Mert, and Anil showed the different implementation methods and tools. Now my question is, how can I evaluate the fairness level of data? And what are the existing metrics, methods to measure the compliance of the FAIR principles? Next. Maybe first we should talk about why do we need to evaluate and what is the benefit of this evaluation. If you think about the FAIR data and FAIR principles, they are very nice guidelines, but implementing them is not always very easy and straightforward. You have to go through the lots of hurdles, finding the community standards, building it, implementing it, aligning your technical architecture with FAIR requirements, and also there are cultural requirements to change the culture of data sharing. Therefore, first thing maybe to do to understand your current status. What is your level of fairness with your existing community standards in your project? Which requirements you already fulfill? And what could be the things that you can change and improve so you can set a roadmap for yourself, a targeted level of fairness? Assessment tools and maturity levels helps you to lay out those steps and create this roadmap. Then when you are using this assessment methods, you can also benchmark your outcomes with others. Next, please. When we are starting this assessment models, one of the challenge was FAIR principles are not very strict. This is intentionally because they want to cover lots of communities and lots of lots of interpretations. What is needed actually, remove this ambiguity and deal with this wide ranges of interpretations. For example, when you say that data described with rich metadata, it might have different interpretations. If you have, for example, keywords about your data set, this is data set about cardiovascular diseases, then do you satisfy this metric? Or if you do you need more metadata about different phenotypes, or do you need how this a single measurement has been made, such as blood pressure taken when patients are standing or sitting? So these are all different implementations, and as a result, different FAIR assessment frameworks appeared. Consequence was we had different metrics, and we cannot compare the outcomes. Then we need to bring all these different methods together and create a community standard and community understanding. Yeah, next slide, please. Here the RDA Research Data Alliance comes into place. Before I talk about the RDA, I would like to take a poll and see if you are familiar with RDA. Are you familiar with RDA recommendations? Are you participating? Any interest or working group? Yeah, please answer the poll so I can understand your familiarity about RDA.
Uh, 20 people have answered. Maybe some more of you would like to give us your input. Okay, I'll stop the poll now. We have 23 answers, more than half. And we see that we have 3 people in the audience that are part of an RDA working group. Here are the results.
Yeah, okay. Yeah, most of the people would like to learn more about available recommendations and outputs. Good. So then I can a little bit talk about the existing recommendations for FAIR data. First, maybe about RDA. RDA is established in 2013 by European Commission, US National Science Foundation, and Australian Government Department of Innovation. And its main aim to promote open science, data sharing, and data reuse across the domains. Next slide, please. Currently, like in less than 10 years, in RDA, we have almost 11,000 members from 137 different countries between different academic fields. And there are almost 100 different groups working on recommendations about how to make this data shareable, how to remove technological and social barriers around data sharing. RDA is an open community. It becoming a member doesn't require any membership fee, and anyone interested can become member by going website and can join working groups on their domains and interest areas. So I would like you to encourage to go and explore health-related working groups. We have more than 10 health-related working groups currently, and they are doing great work on publishing recommendations. Next slide, please. In this talk, I will focus on one specific group, on FAIR Data Maturity Working Group. The aim of this working group is to remove the ambiguity around measurement of FAIR principles and come up with a core criteria for this assessment metrics. This working group worked for 1.5 years with contribution of multiple disciplines and list for indicators for assessing compliance to FAIR principles and explore different evaluation methods. Group's aim was to create a common understanding on these indicators. Next slide, please. In here, you see an overview, like we have 42 indicators and a final report on different, on 4 different FAIR principles. Those indicators expand in these FAIR principles. For example, when we have the principle of metadata and data is identified by globally unique persistent identifier, they divide this into measurable parts and provide some guidance about how to evaluate a specific principle. Next slide, please. In here, you see an example indicator. Each indicator has identifier. It refers to certain principle. It provides a description and also assessment details on how you're gonna assess it. For example, in here, how you can measure the global uniqueness, and there are recommendations on using registry services such as FAIR sharing. Next slide, please. We, as I said, RDA is open to all communities, and different communities has different prioritization and different goals for implementing FAIR principles. Therefore, like there were different opinions about these prioritizations, and RDA tried to come up with a common consensus on those priorities, which part of the FAIR, findable, accessible, interoperable, or reusable, is more important for different research communities. And in here, I would like to ask your opinion. What do you think, which FAIR letter is more important for the health data sets? Are we looking for findability or accessing to this data sets, interoperability, or reusing in different contexts? Do we have some results already, or?
Yes, let's have some more answers. 24 people answered. Maybe some more?
Please vote.
25. Okay. So I end the poll here. And here are the results.
Okay, yeah, most of the people think all of them is important, but if you look the individual ones, interoperability is more prominent on compared to other principles. If you look to RDA prioritization, you will see the other way around. In here, mandatory ones are unfindable and accessible, and you will only see very limited indicators mandatory for the interoperable. This shows the difference between this perception of different domains, and RDA also encourage different domain areas to set their own prioritizations. Next slide, please. Once we have the indicators, we can use different evaluation methods, such as like you can compare this data sets and say this data sets pass or fails, or you can compare the progress towards the fairness, how I can improve certain indicator by stepwise. So this is the area each domain should explore. And next slide, please. I would like to give an example of a project working on enhancing this RDA model for RDA maturity model for a specific domain, which is the life sciences. In FAIR Plus project, aims to develop tools and guidelines for the life sciences, similar to FAIR4Health project, but in the life sciences domain. And in this project, we develop a capability maturity model framework for life sciences for assessing fairness level of data for the specific needs of that life sciences domain. Next slide, please. What FAIR Plus project is looking for, an assessment tool for comparing the benefits and costs of the verification. In this project, we do not target always the highest levels of fairness, but what is the optimum level of fairness when we are looking our business goals, our domain requirements, and what are the capabilities needs to be supported in this FAIR implementation. Next slide, please. Therefore, like in this project, we are taking these RDA indicators as a core and looking at these different domain requirements, such as data interpretability. Data integration is an important topic for life sciences, data repurposing or reproducibility. For each of these fields, we have a certain benefits. For example, data integration reduces time spent for data, and data reproducibility makes using attaining same results by different teams. And for each of them, you need different types of metadata. For one, you need vocabularies on ontologies, and for reproducibility, you need study design and measuring tools. So this is the model for extending RDA indicators. You can find more information on FAIR Plus GitHub. Next slide, please. So what we should be doing actually in health domain too, we should look for the similar model for exploring benefits of FAIR data in healthcare, and like how we can build a maturity models by using existing standards, by leveraging existing standards and extending for the specific needs of FAIR data. In here, I will give the floor to Georgia. We'll talk about FAIR4HELTH.
Thank you. Hi, everyone, and good morning, good afternoon. Karin, could you move the next one? Thank you. Next one. So, where this new project come from? As introduced in the FAIR4Health project, we have evaluated if and how this HL7 FHIR standard could support data verification. And what we have recognized is that this standard could be an enabling factor for the data fairness. Next one. With having this in mind, no, I don't think there is the pool, Catherine. Next slide, please. So, with this in mind, in July last year, we had a webinar in the IMISE, in which we have discussed and tried to discuss how RDA and HL7 could cooperate to promote the data fairness through the HL7 standard. And the result of this webinar has been, the slide, has been the creation of a new, next slide please, the creation of a new proposal for HL7 with the intent to develop an HL7 FHIR implementation guide to provide guidance on how the standard can be used to facilitate the implementation and the assessment of FAIR health data. Next slide. The intent of that project is to facilitate also the collaboration between the HL7 FHIR and FDA community in that purpose. We have mentioned several times FHIR, so I really would like to hear from you. How much do you know about that standard? Okay, do we have the results?
Let's wait a little bit longer. A few more answers to get like 70%. We are at 60% now. That's all. All right.
So let's see.
Okay, so here are the results.
Okay, curious to read more, but there are several people. Okay, it seems that the level of knowledge is quite good. So next slide, maybe we can avoid it to describe. Next slide. Next, I assume that all of you knows what is HL7. Next. We can maybe skip that part and gain some time for the final discussion. Next slide. I assume that you know that FHIR is a new generation standard for in HL7 that use the component that are called resource. And the good thing is that HL7 FHIR is not only a technical standard, but it's mainly a community of people. So next slide. The purpose of this project is to create an implementation guide. But what is an implementation guide in FHIR? It defines a set of rules that describe how the FHIR resource can be used for a specific purpose, and with the documentation that explain how to make this usage of the standard. Usually, it has a web human-readable part, and also a set of formal computable resources that can be used for assessing the conformance of the instances against that guide. And this is what we would like to do also with that project. Next slide. So, as described above, the intent is to provide a guidance on how FHIR can be used for supporting implementation and the assessment of FAIR health data. Next slide. And with two goals, to suggest an assessment methodology, exploring machine-readable and manual assessment method, and also to identify how the standard can support and fulfill the fairness maturity indicator. Next slide. And this is supposed to be done analyzing how the FAIR data conceptual component can map into the FHIR resources, how the FHIR resources can support the maturity indicator and the reproducible health data services, try to identify minimum metadata that can be used for supporting this maturity indicator. Next slide. But there are also other objectives. It's also to try to facilitate the collaboration between the FAIR and FHIR community, enable this cooperative usage of the two paradigms, also providing some cross-model mapping, and as described before, support the fairness assessment. Next slide. To achieve this result, the idea is to build this implementation guide with a large informative guidance, and let's say the true FHIR means a set of conformal resources and example that for specific cases can describe how the fairness could be assessed. Where we are in, next slide, where we are in terms of planning. The project proposal has been approved. We have a sponsor working group, fire management group approved. We are waiting for the final SD steering division and TSC approval. The intent, this is a very challenging deadline. The intent is to have the ballot next May, the STU, the standard for trial use ballot. But what is important is we would like also to promote a fair track at the next FAIR Connectathon starting from January next year. Next slide. So, as you can imagine, we have just started that journey. Next slide. We have a lot of questions that need to be addressed that can be discussed also later on all together. Next slide. But for that reason is the right time to join the group. And if you would like to have, next slide, to have more information about the how to learn more about the project or to get involved, or also to better understand what does it mean to participate to a FAIR Connectathon. Next slide. You can you have a conference page for the project that will be kept updated about the progresses of that HL7 project. There is already a GitHub repository with the source for that implementation guide, and you can follow day by day the development of that guide from the build.fair.org site. Next slide. If you want to learn more about how to get involved or how to participate to the FAIR Connectathon, let's talk about it later on, or you can contact your HL7 affiliate or your RDA chapter, or write to the SOA working group that is the sponsor of that HL7 project. So thank you so much, and really here to hear from you, your opinion, and answer your question. Thank you.
Thank you, Giorgio. I think that we can open the floor for questions, but before that, we have a last poll for the audience. Actually, we have two polls for the audience. This is the first one. What kind of health data standards you're familiar with? Or you have heard about? Okay, I end the poll now, and here are the results. Lots of you know about SNOMED and HL7 FHIR, so those are the top ones, followed by CDA and LOINC. Quite interesting as a result. Thank you. And the second question that we would like to ask you before we go has to do about FAIR data. Do you think we did a good job of telling you about FAIR data? And what's your opinion about the FAIR principles? Okay. So here are the results. I think we did a fairly good job, given that there are some of you that need to know more, but most of you actually are familiar now. Okay, so now I would like to open the floor for questions and your views. We actually had a couple of questions for you, and also to discuss how maybe we can all open our cameras now. The ones that are there. Yeah, so we had a couple of questions regarding how this proceeds, or if you feel that there are certain elements that need to be reflected in FAIR. That was actually my first question for the people on the panel and also people among the audience. So what are your priorities? Some were actually, let me show the slide here. We had a very, sorry, takes time to go back. Yes, so I was inspired actually about the first question, and we saw some really good tools that you developed, and I wonder, you as developers that have done the work, what do you think are the priorities? Where would you start in terms of profiles that need to be mandatory for fairness? Maybe Merck or Anil could take this.
I don't know if I can intervene, waiting for some additional input from Mert and Anil, but I would like to maybe to ask to the audience what are the kind of information, the kind of data that you suppose should be initially shared. Do you think that are, for example, the physiological data as in the question before, the type of information, or information about condition or observation, the first that we need to look at, or there are other that you think will be relevant in the initial phase of this verification of data? And this obviously will reflect the type of FHIR profile that we need to start with. But I would like to hear the audience what they think we need to focus on in this initial phase.
We have actually a question from the audience in regards to that, Giorgio. It reads as follows: regarding physiological signal data formats, there are a number of researchers who are interested in exchanging physiological signal data. There are many formats. I'm not endorsing CDF, but this paper introduced you to this area, and it has the link. So
maybe I can take a little bit from here and talk about this many formats problem. It's very common in life sciences domain too. So like when you are working on an area, there you might have two different problems. Either you don't have any common standard or format, or you might have many of them. So what is probably important for when you are sharing the data, being able to refer those formats and standards, and registries become very important when you are working on FHIR profiles. The standards you applied or referred in FHIR profiles should be registered and should be referenceable. So maybe it's first step towards resolving and moving towards a kind of common understanding and converging to a single standard using registries.
Okay. So for instance, what is the case with the GDF format that was mentioned by the speaker, by the audience here? Is this something that could actually be conveyed by HL7 FHIR? Do you think that this could be a possible measure of fairness?
Yeah, I am not familiar with that specific standard, but if the standard is published in a registry and like have a nice description, and people following that, if they were able to say, okay, I am following this standard with that version, then it will be a measure of fairness and it will be comply with that metrics. But if we cannot refer that standard explicitly, people don't know what we are following as a standard. So like documenting our practices documenting that standards that we use is very important, and we should document them in a machine actionable way, not only on a PDF paper, but in a resolvable URL, so you can find all the information about that standard. So I think that's the one thing maybe we can work on, making these standards visible through the registries.
Yes, indeed. And if we recall the answer of Anil earlier, when he was asked about the formats that are used, he mentioned that he is using essentially data structure neutral formats like comma separated values or Excel. Giorgio, last question. How is this project? You are the leader of this project. How are you gonna think about this approach, going, from Excel style formats into actual FHIR profiles? Do you have any initial views on the subject?
I mean that obviously the scope of that project is not to convert from one format to the other, but to define a set of conformance resources in FHIR to represent in FHIR this information. It's clear that if we would like to support the data fairness, it's important to be able, because the reality is to have different formats around the world, is to be able to enable the mapping of this information in different format in this common. And I believe that, for example, representing this implementation independent format like logical model, and to provide, for example, concept map that allow you to define how to map different format into this common format would facilitate the sharing of information from different sources. So we need to investigate if we need to invest also for developing this logical model, maybe some example concept map, but it's a thing that we need to discuss together in the group. What I would like to invite is the people is to think about the next FHIR Connectathon and if and how we should create a FAIR track there. Because doesn't mean that we need to have a developer. It could be also a way to discuss and to put our hands on. So I really would like to invite all the people to think about how we can maybe organize next January that track, and with which scope and how we would like to play with that fairness by using FHIR.
I see that there was another question that talked about the use of DICOM and images, and I think this applies also to it's the same question essentially to the GDF format question, that there are so many formats around, and we need a way to link that to essentially the FAIR principles, and like Oya said, make this accessible. I think for FAIR4Health, it's important to see what are the requirements and what is our roadmap towards the certification of health data sets, taking into account all these activities and making sure that the data formats are accessible and open so that people can read them. And at the same time, they protect the privacy of the individuals that are recorded in those data sets. Are there any other questions from the audience? Are there any final concluding comments from the panelists?
Yeah,
Alicia? See, please.
Maybe I can. Actually, I'm not in this field. I use the image data to do some applications. But I learned this HL7 and FAIR4Health knowledge from this tutorial. It's a great talk. I think I'm into it somewhat. Maybe I want to learn more in the future. Yeah. I want to find the link between the let's see, HL7. It seems the kind of communication channel or kind of level that will pass the the data, it has the standard. And FAIR data, FAIR is a kind of regularization. It actually confines the data's nature, like findable, accessible, reusable. And the FAIR seems it will be used. I don't know. It is a kind of usable, become a usable outcome. So I don't know. My understanding is correct, or there's a kind of still some.
Yes, I think you are right. We are actually bridging two communities: the data science community with the health interoperability and hospital information community. So there was one community that did research and open science, and another community that actually did healthcare. And the question is, how do you bridge those? And this actually leads to a very pertinent last question that I think we could answer, which is, and maybe Alicia, as the project coordinator, you could weigh into that at a high level, is it says, how do we make sure that we don't violate any EU privacy law in FAIR4Health? We have two real-time, real-world case studies. How do we make sure that EU privacy laws are respected in FAIR4Health?
Yeah, in FAIR4Health project, we are taking into account this kind of issues. So we have in the consortium a partner that is expert in this kind of topics about laws. I don't know if Oya that is has more experience about FAIR compliance, maybe could add some details.
Mm-hmm.
Yeah.
So what I can add in here, there are different, there are lots of challenges around healthcare data to keep this privacy and comply with GDPR, and also like ethical concerns. FAIR data does not only support data sharing within a small consortia, but also like it supports distributed algorithms, sending algorithms, analyzing it distributedly. So I just pasted a link from GoFair initiative. They are looking for how to work with this FAIR data without sharing the data itself and keeping this GDPR privacy and GDPR and privacy regulations intact. So FAIR data makes this kind of data-driven approaches possible, and also within that the data premises without giving data out.
Indeed. Thank you very much, Oya and Alicia. And if I may also mention to people, maybe they can listen back the recording, because what MIMTT actually demonstrated is privacy presenting data mining algorithms, distributed data mining algorithms. And this was actually one of the questions. It's still something that is not well known to the wide research community. But I think one of our key messages, takeaway messages, is that we should do more of these tutorials so people understand that they can actually run algorithms on top of distributed data. They can, without actually sharing the data. So with that, I would like to thank all the attendees that have stayed until the end, and thank the panelists, the participants. And we are really delighted that you are with us in this FAIR4Health RDA operation. And please join us in our journey. Thank you.
Okay, yeah, this is a very good talk. Thank you. I think everybody who is not in this field, this tutorial is valuable and instructive. Thank you, everybody. And before we go, I want to announce that we have another tutorial today that we'll do in, let's see, in about half hour, 24 minutes, 26 minutes. The topic is healthcare innovation in the post-pandemic era. So welcome to join us later in different linkage. We will share the link later, or you can watch it through the stream. Thank you. Yeah, that's what I want to inform. Okay.
Thank you. Yes, let's talk about supply chain and innovation next. Thank you. Bye-bye.
Thank you.
Yeah, thank you, everyone. Thank you. Great talk.